tomorrow.
Okay. So what do we got? Let's get to it.
Yeah. Let's see here. I'm trying to see what page. Could we work on
And work on
piecewise functions?
whatever you want, yes.
Okay, cool.
Now, on piecewise functions, they make you go both ways. In other words, they'll give you the piecewise function and ask you to graph it, or they'll give you the graph and ask you to come up with the piecewise function.
Right.
Now, for those, you're going to need to send me a picture.
Okay.
Because you're not going to be able to verbalize that. So,
okay. Can we do like just examples of them? Like any?
Yeah, I suppose I could. I could bring some up. In fact, let me see what I got. I don't want to, in other words, I have a 5:30, so I can't go over.
No problem.
But let me see. I think I have some piecewise functions on my under algebra.
Okay.
Let me see how hard it is to find them. Wow. Now, let me view list.
Oh, I see one.
Do you?
Yeah. Here, go back to the last page.
Whoops.
Oh, no, you're right.
Hold on, we should be able to see it easier here, actually. Piecewise.
Piecewise, yeah.
In other words, I had these labeled, so.
Okay.
All right. Okay, well, let's go this direction. Since we're short on time, let's take this function and figure out the equation of it.
Okay.
Okay? Because you got to be able to do both. Hold on a minute. Let me get both screens up here that I need. All right. So here's what we're going to do. Our function is going to be some f of x. And it's going to look like that.
Okay.
And there's going to be a domain up here where x is something, and there's going to be a domain. I see 3 pieces on this function. So there's 3 different domains. And you want to start in the upper right. That's where you want to start. And you want to go from left to right. So on this function on the left, what's the domain of that?
So the one, we're talking about the one on the far left?
Yeah, always work from left to right and from top to bottom on piecewise functions, at least if you have a choice. Sometimes they will give it to you with it going from right to left, and you have to deal with it. But in this case, we don't. How can I describe the domain of that line right there? And that's all we're doing. What's it say?
Okay. Well, so it would be, yeah, would it be x plus 2?
No, x is less than negative 2.
Yeah, I'm sorry. Yeah, we're talking.
Look at that and see why that's the case.
Okay.
In other words, that line applies from negative infinity on the x coordinate up to negative 2. And that's the only one. That's the only of the 3 lines that has that domain. Okay? Now, before we write the function for that, let's look at the second domain. I want you to get in the habit of focusing more on the domain than the function for a little bit.
Sure.
What's the domain of the middle one?
Yeah, sure. So it would be, for that one, it would be, let's see, -1 is less than or equal to x.
Let's start with x in the middle, and I can see that there's a left point and a right point. So x has got to be greater than or equal to what?
X has to be greater than or equal to 2.
Negative 2.
Or -2, my bad.
And less than what?
Which is less than 2.
Yes. Now, you see why I use the greater than or equal here and the less than here?
Yeah, because if it's shaded in, then there's an equal sign under the
Closed dot
sign.
means equal or greater than. Open dot means just inequality only. And
Yeah.
finally, what's the third domain?
And then the third domain would be x is greater than or equal to 3.
2.
Or 2. 2, yeah, my bad.
And I can write it like that.
Yeah.
In other words, they don't have to have, notice that my three domains go from negative infinity to positive infinity, right?
Right.
They cover the whole thing. Now, not all piecewise functions will do that. Some will have spaces in the middle, but
Okay.
this is the way to start them out, is deal with the domain.
Okay.
Now, I want to take this function, now let's stay left to right, okay?
Okay.
Normally, I know I'm looking at three straight lines, right?
Mm-hmm.
So
Yeah.
I'm dealing with linear equations that I should be able to write in this format,
Right.
okay? However, notice, let's do the middle one first, just so I can illustrate a point.
Sure.
If I'm going to write the middle function, that's that one right there, and
Uh-huh.
I'm going to write it in mx plus b format.
Mm-hmm.
What's b?
B would be the y-intercept,
Which is?
which is, well, what we read on the right, right?
No, we're doing the middle piece. Where does it cross
Um,
the y-axis?
at 0.
Okay. What's its slope?
1/2 x.
Exactly. Up 1 to the right, or up 1 to the right 2.
Yeah.
So there's our equation. I'm not going to write the 0. So f of x, which is the same as y,
Mm-hmm.
equal to 1/2 x for that middle
Right.
portion of the piecewise function.
Okay.
Okay. Now, let's go to the one on the far left. It's a
Okay.
little harder because notice that it doesn't cross the y-axis.
No, you have to like, don't you have to like estimate where it would cross on the y-intercept?
Let's figure out the slope first. What's the slope?
Okay. So the slope would be 1, 4/2.
Rise over run.
So go up. Let's see here. 1, 2, 3, 4.
No, it's only going up. If you go from this point here, let me use my cursor because I know you can see that. If I go from this point here, I got to go up 3, and I
Oh,
got to
that's
go
just
to the
up 3.
right
Yeah, my
3.
bad. Right. So 3/3, which is 1.
1. So it's 1x plus b.
Yeah.
Now, how can I get b? Because I
Well, you could.
put in this. That's not a function. In other words, I
Right.
want it to be all y's and x's only. So how would I solve for b for that left part?
Um, well, we could find a point
Plug
on
in,
the.
plug in a point that's on the curve or the line.
Uh-huh. Hmm.
Its x and y coordinate into this
Right.
equation, and that will allow you to solve for b. So what's the
Right.
easiest point to plug in?
We could do 2 comma 1.
That point isn't on the curve. That's on the middle
Or,
part. We need
or
the
2
point,
0. Let's do 2 0. Yeah.
you mean negative 2, 0.
Negative 2 0. Yeah, my bad.
Okay. All right. That means y would be 0.
Mm-hmm.
I don't need that 1 anymore, but the x coordinate is minus 2, and that allows me to solve for b. So b is equal to 2. So my
Okay.
equation is y equals what? What's the, of
It would be, yeah, so y equals 1x plus 2.
course, I don't write the 1. Okay.
Right.
All right.
Okay.
So that's how we're going to do these.
Okay,
Okay.
cool.
Now, the one on the far right, what's the equation of horizontal lines look like?
It would be x is equal to,
Horizontal lines
or,
are always y equal. Vertical lines are x equal.
right, yeah, my bad. So it would be x or y is equal to positive 2.
Yeah.
Mm-hmm.
And why is that the case? Well, notice
Because
that
that's where the
no
y-intercept
matter what
is.
x is equal to, y is equal to 2, right?
Right,
So
yeah.
it's got to be y equal to. If I have
Uh-huh.
a vertical line, well, then no matter what y is equal to, x is equal to this number here. So
Mm-hmm.
the equation of vertical lines is x equals whatever that number is. The equation of horizontal lines is y equals.
Okay.
Okay? So we've just done the hardest one, where
Uh-huh.
they give you a graph and you have to put it into the equation.
Mm-hmm.
Okay? We got 10 minutes more. It should give us time to at least do one of these where they give you the piecewise and they want you to graph it.
Okay.
Um, how come I can't pull this up? Oh, that's because it's my picture. I
Mm-hmm.
was sitting there thinking, you didn't send me the big enough picture for me to see the next problem.
No
But it
problem.
wasn't your problem, it was mine.
Mm-hmm.
I'm going to make one up based on this one I'm looking at here.
Okay.
I'm going to say that, and this time I'm going to use y notation.
Mm-hmm.
So y is equal to 2 whenever x is less than or equal to minus 3. Notice that that starts from the far left.
Uh-huh.
Y is equal to 4 whenever x is greater than 0 and less than 2.
Mm-hmm.
And y is equal to 5 whenever x is greater than or equal to 2. Okay?
Okay.
Now, notice that that does not cover all real numbers.
No.
It covers from negative infinity to minus 3, then it covers from 0 to 2, and then it covers all numbers greater than 2.
Okay.
So always start there and graph that. What's y equal to look like?
Um, so you would start at 2 on the y-axis, and then it'd be a closed circle, and then you'd go to the right.
A horizontal line like that.
Okay. So would you just do like 2 minus 3, like that's where your point would be?
No, there's no relationship between this 2 and this minus 3. This
There
minus
is.
3 talks about the domain. In other words, it's talking about that area right there.
Gotcha.
Okay?
Then why would you put it on like minus 3?
Because that's the domain. In other words, it's whenever x is less than or equal to minus 3,
Mm-hmm.
then the function is y equal 2.
Okay.
And this could be any number you want. In other words, if this would have said minus 4, then I would only draw the horizontal line up to the minus 4 point.
Okay.
Okay? Now let's take the middle part.
Okay. So it would be, so we would start on 4 on the y-intercepts.
Okay? But what's the domain of the middle part?
0 and then 2.
So now we're talking about this area right here. This is where we want to draw the middle function.
Okay.
Okay? And that's the
Okay.
way to think about these. Always pay attention to your domain before you worry about the function.
Okay.
Okay? Well, the function says y is equal to 4, and
Mm-hmm.
it's open at both ends. So
Right.
you go from there to there. There's the
Okay.
part. Notice that I
Okay.
have nothing between -3 and 0.
No.
That's okay. There didn't have to be anything there. It's just this problem does not cover the whole entire real number domain. It's
Okay.
split up. Now, it does go all the way to the right. So what's the next thing I need to do?
And then, so for the last one, we would,
And then the
x is
last
greater
one
than,
is everything in that.
right. So we would start at 5 on the y-intercept, and then go to the
With a
right.
closed or open dot.
It'd be closed dot.
And I wouldn't start on the y-intercept. I would start right there.
No.
It's
Yeah.
where the y value is equal to 5.
Mm-hmm.
But I'm not starting on the y-axis. That's not in my domain. My domain is only where x is greater than or equal to 2.
Right.
So that's
Should
how
go
that
that way.
thing would look.
Okay.
Okay? Now,
Uh-huh.
if this was a little more complicated, let me give you a little more complicated one. I'll make
Sure.
it a two-piece.
Okay.
Where do I start?
Okay. So we would start, so for the first one, x is less than 0, so we would start at 0.
So this whole area over here is where I'm going to draw this first function.
Right.
And the first function is 2x plus 3. Where do I start that?
At plus 3. And then we would go
Open or
to,
closed circle?
it would be an open.
Okay.
And then we would go up to the left 1.
If I do that, if I go
Or
up 2 and to the left and I connect those two, what's the slope on that thing?
minus 2 over 1.
Ah, it's not what I want. I want a
No.
slope of positive. So I got to do something different.
Okay.
How do I get a positive slope?
You would do down 2 to the 1 left.
Exactly.
Okay.
Now I can connect those, extend that all the way to the end.
Mm-hmm.
That's right for that part of the domain. Now how about the rest of it? How do I graph x minus 1 whenever I'm on this part of the curve?
Yeah, so you would do, you'd start at minus 1.
Okay.
And then you just go down 1 to the right 1.
That would give me a negative slope.
Or that'd give you negative, so you go down, or up 1 over 1 to the right.
Yeah, it doesn't matter whether you go up and right or down and left.
Okay.
Both give you the same positive slope. But
Yeah.
since I'm graphing everything to the right of the y-axis, I might as well go up 1 and to the right 1.
Okay.
And I'm starting right there, because I'm starting whenever x is greater than or equal to 0. So this one is going to look like that.
Okay. Yeah.
And that's really, piecewise functions are really easy, Dylan. It's just
Mm-hmm.
3 simple functions in 3 different domains. And that's the
Right.
way to think about it. That's one domain, that's another domain. And
Okay.
just graph that function in the proper area, and you
Uh-huh.
have it down pat.
Okay. That makes sense.
All right.
Cool.
I'll let you go. I got a 5:30 I got to run to, so
Yeah. No problem.
I'll talk to you next session.
Sounds good. Thank you, Mr. Cowan.
All right, Dylan. Bye-bye.
All right. Bye-bye.